Live?
Yes,
We're
we
live.
welcome back, everyone. Another week, another stream. This time, Steven's in the driver's seat.
Yeah,
Uh,
we're talking about my stuff today.
yeah, some really cool stuff. I'm
Yeah.
sure you've seen the thumbnail. If you haven't, just hang tight for a few minutes. And we got a special dual camera setup, so we'll be talking a lot about uh, parts and cursed 3D printing,
Cursed 3D printing, forbidden techniques.
forbidden technology.
Yeah, the things that they don't want you to know how to do in slicing.
Yeah, stuff that will break your brain. Yeah.
This is gonna be fun. You guys haven't seen the whole display we have yet, but it's pretty cool.
Why don't I switch to it?
Yeah.
Can stop.
Well, there's nothing else to say. Yeah, let's get
Yeah,
right
there's
into
really
it.
not much. We should show
This
and not say.
this stream is kind of a break from all the Quinley Vision stuff that we've been talking about. Uh, This is more of just like a cool time to talk about some some cool stuff, some cool 3D prints. So here's what we've got.
Okay. Oh, we should probably say hi to everyone. We've got
Yes,
Carlo.
hello to guys in the chat.
Uh, nice to see you, Kevin, and we've actually got Al on the stream this time too, which is very exciting.
Hello, Al. Oh, I didn't know you had like you had a whole Fibonacci spiral in your profile. That's cool.
Yeah.
I didn't know what it was.
How do I turn on the comment overlay?
Oh, that's the browser. Oh, you know what? I think I need to do this. Here, give me a second.
Okay, sure, no problem. Yeah, while we get settled in, forbidden technique sounds like some ninja technique. Yeah, this is definitely like some slicing ninjutsu. It's pretty crazy. Uh, and the cool thing is, I have no idea how Steven did any of this, so I'm gonna be asking him a lot of questions that I'm sure everyone else in the chat is gonna have too. So I'm really excited to learn more about this.
Yeah, so I'll be kind of telling you guys how you can get some of these effects on your 3D prints at home. I'll do some Cura demos. I'll do some really interesting like non-planar G-code demos. Just some basic stuff to get you started. But I'll tell you about like sort of my process and how I learned how to do this stuff and how you can do it too. So,
Fibonacci, easy as 1, 1, 2, 3.
hey, that's pretty cool.
Cool. Yeah, so what should we what should we start with?
What should we start with? Well, I think we should start with what a normal print is,
Okay.
and then we get weird from there.
So like
So
nothing in this web. Oh,
we have the eggs.
the
So the eggs are pretty normal, right? Here's a very good example of a normal print. So this is a 3D print with normal layers, and this is called a planar print, which is all the 3D printing that you've probably done, um, unless you start dabbling in non-planar G-code. But we printed these eggs on a Quinley. We printed them all in a row, actually, using the automatic part release. So we have all these interesting different shapes, and these are all from Thingiverse. We have 3D Musketeers in the chat. Hello.
nice to see you again. Um, yeah, but so even though these look very different from one another, they're all planar prints. Now, like what
Yeah.
does that actually mean? Like I can take a guess that it means that you're printing in the same plane for each layer, but
Yeah.
like what's the difference between a planar and non-planar?
Well, a planar print is your z-axis doesn't move during a layer. So if you have
Okay.
like one layer here, you have another layer directly on top, and then another layer, and then another layer. And there's no like, the z-axis doesn't move. That's kind of the whole point of a non-planar print is that the z-axis is moving or that the layers aren't aligned in like flat. So you can see, let's check out this print for a second. This is a very interesting looking print. If I can get the camera to focus on it. Something like this. But these drooping bits, those aren't flat, right? They're obviously drooping because of gravity. So
Mhm.
I will consider this non-planar because these droops are drooping because of gravity. So Obviously, these lines aren't aligned with any sort of layer on the print. They're just drooping because of gravity. And I'm going to show you guys how I printed this in Cura in a bit.
This is a pretty good description from Al. Planar would be 2.5D, which I guess is like
Yeah.
flat with thickness, whereas non-planar is like true 3D. So what you're doing is true 3D printing
Yes.
rather than just stacking flat planes on top of one
Yeah.
layer. But this is an interesting distinction you've made that was maybe a little bit quick to catch, but this was printed with flat layers. It was
Yes.
actually almost like a post process that caused it to droop. In this case, it was happening while you were printing,
Yeah.
because the filament was still hot. But I've seen examples of non-planar prints where, like there's that lion head that people will print where you hit it with a blow dryer and then use that to warp.
Oh yeah, the hairy lion.
So this is kind of the same concept, right?
Same idea,
Okay.
yes. It's using individual filament strands and sort of the force of gravity to make them non-planar. Even though they were printed flat, they drooped, so they're no longer aligned with any other layers.
Mm-hmm. This one too, right?
Yeah, so we've got more prints here. Check out this guy. So this one is a bit more of a simpler print because it's actually one of these, or there's three of these guys in this.
Okay.
So the whole idea for this triple helix was, what if I just repeated the single helix 3 times? So I might as well just show you the Cura representation of this part, or the STL file, because I think it's pretty cool. Let's see if I can just do this. Yeah. So here's the STL file, and as you can see, all the loops are straight, they're flat, but that's just in the slicer. So I designed this with the intention that the droops would droop during printing. So these lines aren't going to stay floating in midair because there's nothing to support them.
Mm-hmm.
So they have to go somewhere. And
hit transition.
Oh, yeah, good point.
Now they can see what we're talking
Now
about.
you can see what I'm talking about. So you can see these loops here. I'll just zoom out for a second because I did some stuff. But this is the part as an STL file. And so I actually modeled in every loop individually and used like a repeating pattern. So I didn't do this all by hand, but these are all modeled in the CAD file. So it turned that into an STL and I brought that into Cura. And now when we look at the loops individually, there's nothing supporting them. And I'm just relying on gravity to pull the loops down and give them like a much nicer, in my opinion, effect. Because this doesn't really look, all that interesting. It'd be really cool if you could print like this, I guess. But in real life, I think the droopiness adds something to it, adds a little aesthetic to it. So,
and I think one of the really important things you were mentioning to me earlier was, it's not just as simple as sticking it into Cura and slicing it, because when you have loose plastic like drooping around, you have to consider things like the direction of the nozzle and where the nozzle is starting and ending. So
yeah.
Could you maybe explain a bit more about that? Because to me that was something that wasn't immediately obvious. Like,
yeah,
so there's a lot to think about.
There is a lot to consider when designing a print like this. So, for example, all of these loops are 1 layer thick, and I designed them to be exactly 0.5 millimeter thick. And all of these lines are 2 nozzle diameters in width. So you can see that there's only 2 lines, an inner wall and an outer wall. That's just how Cura needs to print stuff. It needs to do an inner and an outer wall. So that was kind of a limitation. And one of the most, I guess, challenging problems was figuring out this Z seam. So if you look here, the Z seam, these are these white little dots on Cura. And if the Z seam starts in midair, so if you start printing in midair, then it's not going to connect to anything. So these groups aren't going to be connect it to anything. So I needed to force the Z seam to be as close to the center as possible. So in this case, I just kind of got lucky in that I could set the Z seam to the center and it would make it as close to the center as possible. So that's how we get these nice white lines going all the way down to the center of the print.
So in other words, you're forcing the layer to start on the support pillar, like those thick pillars, and that way whenever a loop is drawn, it's always being drawn out from an existing part of the print. It's not starting in midair or anything like that.
So I'm going to go onto a single layer just to show you what I mean. So when it starts this loop, it's starting from, actually I'm just going to bring it so you can see what it used to print.
Mm-hmm.
So it's starting from the actual base, right? These helix spirals go all the way up.
And that's like fully supported.
That's fully supported. And now it's breaking away from the helix to do the loop, and it's coming back. And so you can see that that whole loop is a continuous thing. It didn't start in the middle of the loop. It started at, on the helix and it ended on the helix.
Mm-hmm.
So the whole thing is supported. And then it does the other side and continues printing.
Can you switch to the webcam? Because I want to show something really cool.
Yeah.
You might have noticed when Stephen was like cutting through that one layer, it prints the outer wall of the loop in one direction and the inner wall of the loop in the other. And actually you end up getting like 2 loops per layer and they're kind of pointing in different directions. Like I think this is the outer wall.
Cause it to like,
yeah, hold on.
Focus.
Oh, come on.
Yeah, because there's 2 different loops, and actually the direction that they're printed does make a difference. So, and it looks like you can see the 2 loops.
Yeah, so here's like probably the outer wall, and then below that you've got the inner. I mean, I could have them backwards, but
it could be backwards. I don't even know.
You kind of end up with like 2 separate, very different shapes coming out of the one loop, which I thought was really interesting.
And actually, I have another model here, which is the same thing, but with much smaller loops. So this is actually, if you want to see how the thumbnail was created, it was pretty much this.
Nice.
But these loops are a lot smaller, so they actually don't have that effect that Matteo was talking about. And I actually kind of like this look too. It looks kind of like these lines were knitted together. And also, you get these sort of DNA-looking strands going across on this print. I think we're focusing the camera manually now.
Yeah.
To get.
There we go.
Ooh, nice and clear. Yeah. So these lines are these loops are a lot smaller, and since I made it in CAD, it wasn't too hard just to change the dimension of one circle, and then it patterned it over to this side and to this side, and so you don't have to worry. It didn't take me hours and hours to change all the circle diameters. But yeah, you can do this this design in Fusion 360 if that's what you're into, or any other CAD program. You just need to make sure that you're designing for the right layer height and nozzle size so that it works out in Cura.
Could we have a bit more volume? Okay, is this better? Hopefully this changed it.
Let us know.
I was saying the droopiness adds an organic feel. It definitely does. It's kind of consistent and inconsistent at the same time, which I think is cool. Like it's a little bit unpredictable, but you do get these like consistently repeating patterns. And I was actually really impressed by how consistent it could be.
Yeah, so this is an example of like one thing I think is a very consistent, inconsistent pattern. Like it's drooping, which you can't control. You just have to make sure that the print head does a loop. But the cooling and the fans all have an effect on the final shape of this stuff. And I really didn't. This was my first attempt at this shape, by the way. I didn't plan much more than just to have it droop, and the droops turned out really, really nice, and much nicer than I thought they would.
I'm sure you could also adjust the shape by changing the cooling fan speed.
Yes. Yeah, I want to do some tests on that. I haven't really tried. So like printing without a cooling fan actually doesn't work, but changing the fan speed can help. So when you print without a fan, what it does is it just disconnects. The loop doesn't stay intact when it prints the whole thing.
Actually, Henry literally,
Oh
this
yeah.
is a good timing on the comment. Yeah, I'm sure that the thermal properties of the filament are going to change what the drooping looks like and what the bridging looks like.
Yeah, so the an important thing for doing loops is that you actually have a filament that can be cooled. So you can't really use high temperature materials like I don't know, polycarbonate or ABS because if you use a cooling fan at any high speed, then the layers won't adhere and you'll get all kinds of warping. So these were all done in PLA, but you can probably get away with maybe like a PETG on a 30% fan speed or something.
Hmm.
And I actually found there was quite a lot of difference between normal PLA and then like a silk PLA. I found that silk PLA isn't as consistent in the drooping. Um, this is silk PLA, and I did it with smaller loops because the bigger loops didn't look very good because they were very inconsistent. Um,
Do you think
yeah.
it's do you think it's due to the silk or due to the color change? Because I know pigment can affect filament properties.
Oh yeah, so I actually tried it using this type of silk, which is a consistent color, and this had the same thing. It was very kind of like stretchy in a way. It's really hard to describe, but it didn't flow as consistently as like this white PLA.
Like, if there was ever a Sleeping Beauty themed after 3D printing, this would be the name of the dwarves.
Droopy, stringy, and zit.
Unlucky, is it?
TPU, actually, that'd be interesting. That would be really interesting. You get a whole
That'd be
squishy
so
print.
interesting.
I really want to try
I
TPU
think
now.
I think even though the harder ones like TPC or TPE would be really interesting with this.
Yeah, yeah, that's given me an idea. I didn't even consider doing it with TPU, but that's a really cool idea. So this is the type of non-planar that I call drooping. So
Drooping.
it's not true non-planar because the z-axis didn't move when it printed it, but the result is non-planar.
Hmm.
So I'm going to consider it forbidden because no one tells you to do stuff like this,
It's
right?
like a forbidden use of Kara.
Yeah, you definitely always want to support your overhangs unless you're trying to droop your print on purpose.
Yeah.
So this was drooping.
So that's like this everything we've shown up until now you can do in Kara.
Yes.
Okay.
Yeah, and it can take some fiddling with like the Z seam, for example. You never want the Z seam to start halfway through a loop, but it's usually not too hard if your shape is symmetrical or in my case it's got radial symmetry in a way. So you can always tell it to start as close to the center as possible, and it'll start and it won't start in the middle of the line. So yeah, Mateo is showing.
Well, never mind.
Yeah, there's also a little bit more of this model that I think might be interesting to you. There's not just the loops, but there's these like connecting bits. So this is what I would call intentional stringing. If I can get the right layer to show up. Yeah, this guy. So I just showed drooping. Now this is intentional stringing. So if you see on this model, these bridges, I guess, or strings, are um, connected on both ends. So in this case, they don't droop, they actually just bridge cleanly across. And if I just switch quickly back to the other view,
Hit transition.
yeah, you can see that these, yeah,
Yeah.
these strings are supported on both ends. So this is what I will call intentional stringing, and it's very similar to the drooping, but there's no drooping because it's a string.
Kind of reminds me of when people do those insane bridge tests where it's like, you're doing full extrusion multiplier and you're just running the nozzle slightly faster than it's extruding to keep tension
Oh yeah,
across the filament so
yeah,
that it doesn't droop. Because these like look very straight.
yeah. So these are actually I don't know why they're so straight. Like I didn't intentionally cause them to be straight. Like has um they would be straight if there was tension on them the whole time, which I think is just because they're not supported. There's no such thing as line width anymore. It's more like line diameter
Right.
because there's nothing squishing
There's
it into
nothing
a flat
squishing.
line. So, um,
That's often the issue you see with the underside of bridges, right?
yeah.
Why you have to increase the extrusion multipliers because you'll end up with like little non-squished, like perfectly circular lines at the bottom. That's why all
Hmm.
like if you ever look at the underside of a bridge on a print, it always looks under extruded, even though it's really not. It just doesn't support it.
Oh, I can show you like a little sneak peek of something in the future that we're talk
Okay.
about in a little bit, but
Nice.
little sneak peek for something that was printed as a bridge without support. If you guys can see
Yeah,
this.
I guess talking about tension in 3D prints and
Tension in strings unsupported. This is exactly a very nice,
the
what's it called? Segue. Segue
Sugu.
into into this next one.
Should we go into the next one?
We could, yeah. I can always talk about other stuff more if you guys have questions.
Yeah, definitely. If you have any questions about this, Steven is the expert, so definitely post. Oh, actually, we might have missed a couple questions. Maybe before we Sugu,
Yeah, let's do some questions.
let's see some questions.
Ooh,
Would a fiber-filled material with cooling create stiffer branches? Probably.
I imagine it would. Because I
Hmm.
think PLA is already fairly stiff as a material, but if there was some like glass fiber, carbon fiber in there with really hard, like really fast cooling, it could actually, um, yeah, be better supported, I guess. Um, and I think there could be a lot more testing to be done on this, trying different materials, trying different fan speeds, different printing temperatures. Fun fact, this PLA was actually printed at 250 degrees.
Yeah.
And because I was actually trying to get it super hot so that the drooping would work better. That was just my initial guess. But as you can see, it didn't really droop very much at all. And that was at 250. So I think it's the tension in the filament when it was dragging these lines across, the tension kept them straight.
I know one thing you'd have to be pretty careful about is with because fiber-filled filaments are typically stiffer too, and
Hmm.
I'm not sure how this translates to when they're molten, but I would expect that you would have to worry about the line snapping, like either under
Yeah.
its own weight or you putting too much tension on it. Um, yeah, that'd be a really interesting thing to test.
Yeah, so I haven't shown I should have brought maybe some of my fails as well because there was failed intentional fails that didn't do what I thought they would do.
Yeah.
But there was so if you print these without a fan, then the loops won't connect to each other sometimes. So the loop will break mid loop and it'll just look really ugly. It'll look like just lines going everywhere and
Hmm.
spaghetti. You know, Quinley Vision would go nuts on this. It might
Yeah,
already go
it
nuts
might
on this.
already.
We really need to try this through Quinley Vision.
One thing that I know is if it's too thick, it doesn't detect it as stringing, so it might
Yeah.
actually do okay, but yeah, it'd be interesting to see.
Because I don't even know, would this consider it spaghetti? Because it's very straight.
It's
Like
like it's
these lines are straight.
too straight to be spaghetti, and it's like I think this would for sure catch as
This
spaghetti.
is gonna look like spaghetti.
Yeah, a hundred
Because
percent.
these are all going in different directions.
Yeah, it's like and it's out of plane. Like that's one of the things that maybe Quinley Vision will work really poorly with non-planar printing because it does notice when things are out of plane.
Yeah.
So that could be an issue. There was actually another thing that Al had suggested where printing perimeters and walls last might give neat variation.
Yes, I
That
think.
makes sense. I think you have to, right?
Yeah, actually, in all of these, I believe I just print the walls. There's only outer walls, and there's no inner walls. So,
I can go
um,
back to Kira while you're explaining it.
yeah, yeah. So if you can see this, the red lines, these are all just outer walls.
It's
So it's a very minimal print. There's like one line of infill because I forgot to turn off infill. But in these prints, there's no infill. It's just one wall thickness on the helix.
And actually, that also answers one of Kevin's questions, which was how many walls in the upright. So it's just a
Yeah.
single wall. But Steven's got the extrusion width.
It's 0.8 and it's at an overhang, but it's for some reason it doesn't suffer from any issue.
Yeah, it doesn't seem to be that steep of an overhang. Like this is what,
It's maybe like
40?
30 even.
Yeah.
Yeah, so it's not too steep.
It
And
just depends how you're measuring.
yeah, I had to Google what the angle of a helix is based on its like pitch and radius.
Mhm.
And you can get a number, so you can make sure that you're not going over 45 degrees, but I don't remember what this one is. I think it was like 37 actually. Yeah.
And then Steph was asking, why did it not droop on the gray and orange print? And that was because um, that was just
Yeah.
because the loops were a lot smaller, so there wasn't
Yeah.
enough material to really droop.
I can actually bring the other
Sure.
I'll bring the other loop in because I have another uh yeah, this guy. Just the model, please. So you can see I have some support blocking stuff going on too. Yeah. I don't know if that shows up so well. Let's get rid of this. Get rid of it.
But it looks like the same.
Those are exactly the same, aren't they?
Yeah.
Maybe I need to grab the other one. If that doesn't work, you're just gonna have to trust me that they're different.
Oh yeah, there's a big difference.
Yeah. Oh yeah, here we go. So
The loops are smaller on that one.
yeah, if you can see it, the loops are
Maybe
smaller.
show it top down.
Yeah, true. Yeah, there's no easy way to show it, but the loops are just smaller.
The circles. Yeah.
That's all I'm trying to show here. Yeah.
So less material to droop and less unsupported parts of the print.
Yeah. And I can show you guys what these little white guys, these white prints look like. So this was the what I'm just gonna call it. It was like a single helix. But this is the. I'm just gonna show the white print. This guy. Oh, actually, this guy. So actually, this is my favorite of the two, and it has this sort of asymmetric look, where there's only one line of loops going, and the other one has 3 different lines of loops going. So yeah, we can look at the model. Another like the same ideas are applied here. So the loops are spaced according to the layer height of the print. So, you know, the loops themselves are 0.5 millimeter thick, and there's, I believe, 5 millimeters in between each loop, or maybe 2 millimeters in between each loop. So if you're trying to do this yourself, you have to model with your print settings in mind. Otherwise, you're going to miss loops. That's a pretty cool
Yeah, that's super cool.
time lapse. I guess you could you could almost do it like that.
Cool. Let's see if there are any other questions. If not, we should segue to the other one.
Oh yeah, we need to transition.
Oh yeah.
Yeah, here, these are the two. So this is the one that you were seeing in Cura. This one on the right, and the one on the left is the same thing but with more loops. So I think this guy is my favorite, but I think this one looks pretty cool too.
Kevin's asking, is it phase mode? Not really.
No, they're not phase mode. It was just a single wall print.
Yeah.
So
So there is a seam.
yeah, there is a seam. It almost could be possible to do this in phase mode if you really, really try hard to make it work, but I don't think it's worth the effort. In fact, there's a better program for doing stuff like that, which I'll show you guys later. It's called Full Control G-Code, and
Yeah.
it's really cool.
Yeah, so all of this stuff you can do in Cura so far.
Yeah.
Okay, let's show the
Okay.
impossible bridging.
The impossible bridging. So I've got a couple interesting. These are just experiments. They're not supposed to be as aesthetic or beautiful as the other ones, but this is a print, and it was printed like vertically like this
With no support.
with no support. And you can see like those are pretty big overhangs, like this is my hand, right? And that those overhangs are not insignificant. And I'm gonna show you the I guess the underside of these, if I can get the lighting.
That's good.
Yeah. So that's what the underside of the print looks like. And this was done in a really interesting way, and I've got some video to pull up to show a bit better how it was done. So if you just give me a moment here.
What do you think this angle is? Was this 90 degrees in the model, or
In the model it was 90. Yeah.
and after in
After-
real life it's like 89.
After temperature and warping and all that, yeah, it was closer to 89. Let me see. Get my web browser up.
Make sure to transition.
Okay, so here's a little Google Photos collection of my prints. We can just go through the ones that we've done so far. So there's your thumbnail. This is the black one, same angle. Nice photo of the black one. This is another intentional stringing print that I didn't bring because it was super delicate. I didn't want to crush it. But this was also designed with the same ideas in mind, using strings, connecting 2 points, and modeling those strings in using CAD.
It's interesting, like you could maybe even consider them for like supporting certain models. I don't know. Like,
Yeah.
structurally. I mean, it's very weak, but
It's kind of like wire printing. It's an
Yeah.
option in Cura. I haven't tried wire printing before because this is using just the Cura as you normally would use it. Because you can see like these little pillars are just actually like modeled cylinders that it's still printing. So it's not just printing thin lines.
I think people want to get to the impossible bridging.
Yeah. So I'll go to
Here, just
the bridging.
like, yeah, everyone wants to know. Okay,
Yeah, I'll go to the
skip to it.
I'll go to it.
We can't tease it anymore.
So here it is.
This video is so cool. When you showed me this the first time,
Oh, it skipped the halfway one. So this is. Oh, can I get it higher quality, please?
there we
1080p.
go. Kinda.
No, that's how it is when it's actually doing the first line. So it's
So this is 1 layer thick right now.
yeah,
That's insane, right?
the 1 layer thick.
90
overhang.
degree overhang. Could you do other shapes? Like other than a circle? Is that possible?
It actually kind of has to be a circle.
That's okay.
Because there's the whole tension aspect of it. It needs to wrap around something. So it needs to wrap around the circle that just came before it.
Because I'm wondering, like, could you do concentric circles, but then not print portions of it
So you could maybe do it so that they slowly deform into a different shape,
into it?
but it would have to be a very gradual
Yeah.
transition using lots of math. And I didn't feel like doing any math.
Yeah.
But I guess you could potentially turn this into like maybe a rectangular overhang if you slowly transition from a circle to a rectangle.
That's what I'm thinking. Yeah.
Yeah, and I think Cura would have a really hard time doing that because this was actually done during Cura.
This was in Cura.
This was using Cura. Yeah,
So it's like a concentric top layer or something.
this is a completely separate part actually. So the whole T shape is a different part, and that's actually the bottom layer of another part.
Okay, got it.
So that's kind of how I was able to
That's crazy.
get this effect.
And is it like the cooling? I'm sure. It's printed really hot and with the cooling fan on max, or
This one is not printed hot. It's at 200 degrees. So
Okay.
cool. I actually wanted it to be as cold as possible, really. Um, and the cooling fan is at full blast. Yeah. And the lines are also really thin. So it's a zero point 0.8 nozzle, but the lines are only 0.4.
Okay, so
There's a little bit of overlap.
that's nice, yeah, because the nozzle is now, whenever it does the new line, it's actually touching the previous line, probably remelting it to some extent.
Yeah.
That's
Yeah,
sort of
I've tried.
interesting.
I have about 20 of these in a drawer at home because they're all worse than this. But
Yeah, this is crazy.
it took a while to figure out how to get it looking that good.
Yeah. So this is also done in Cura. So this is just another cursed Cura technique.
Cursed Cura hack. Yeah. I'm spoiling everything, but I had another. Well, I can just show it to you on the webcam because I have it here. Um, let's transition back. So that was this, and you can see after it printed the bottom layers, it sort of warped a little bit. And I've tried a few things to, I guess, reduce that effect. Um, but I believe it's when it does these when it does lines back and forth in one direction, it kind of like squeezes
In
and
one
pulls these up.
extremes.
Yeah, so I think in the future I might try having it concentric the whole way around,
Mhm.
because then the forces will be more even. Yeah. But yeah, how many
Yeah, that
layers is
makes
it?
sense.
I think it's about 5.
But you could do it with one.
You could do it with one.
Actually,
It
it
might
looks
actually look better with
yeah,
one.
it looks better
Oh,
with
I should do that. I should just stop the print after that
yeah.
first layer. Oh, you've given me a great idea.
This is okay. Could this be done on the inner diameter of the circle instead of the outer? Outs. Oh, that's a good question. Can you do outside in? So if you had like if you wanted to do it as a top layer
Yeah.
to a cylinder or something, could you like build from the outside in? I feel like the inside would be
No.
too hot.
No, because actually what happens is the filament wraps around it like a spiral. So it needs a bit of tension on it. And I guess if you're going from the outside in, there's nothing sort of spreading the filament from the center, unless you print it so fast it gets like centrifugal force. But I
You'd
don't
have to
think
like
that'll
have
work.
tension on it and still have enough material there to stick to the line next to it. I think it'd be too. I don't know how you would do that. And I
Yeah,
can also
I don't
see,
think you could actually do it in the reverse direction.
and in the middle too, once you got to the middle, the filament from the previous loops would remain too hot.
Yeah, it would get smaller and smaller and then it would overheat. Yeah, in the middle it would droop. Yeah, so this is only possible from the inside out. But I've been thinking about how you could generalize this to get overhangs on any surface, like as a feature in Cura, you know, like automatically create a 90-degree overhang using these circles as a starting point, and then just printing on top of the circles. Any
Figured
Cura developers in the chat?
it.
Hit me up.
Yeah. Call back Ultimaker.
Yeah, yeah. So that's my idea for 90-degree overhangs, and I've got a better demonstration or another demonstration of it here. So this is a print that I used. This was also printed in Cura or using Cura, but it uses the same idea to get this 85-degree overhang, but it's actually consisting of a bunch of uh, concentric circles. I'll see if I can get it focusing on the camera. Yeah, so you can see how they sort of build out from the center. And actually that effect you said earlier, Matteo, in the center where the lines become really close, they sort of droop a little bit more. You
Hmm.
can see like right there, the center droops a little bit. So it doesn't look super nice, um, but it does actually get that overhang working to some extent. So there was no supports used in the printing of this model.
And actually, I think this answers Henry's question, which like this is kind of
Yeah, it would work as a
demonstrating
semicircle. Yeah.
the semicircle. Yeah.
So this actually goes back and forth um, instead of all the way around. And I have this in Cura too, so I'll show how this looks sort of when it's being printed. Just give me a moment. Um, okay.
Did you just stop it early? Why is there exposed
I
infill?
stopped it early, yeah, because it fell off. If you can see the bottom, it kind of warped, or like,
Oh
because the
yeah,
heat bed was hot, there was so much like force. It's basically a whole cantilever, and it eventually peeled up off the bed.
yeah.
So
Oh, that's crazy.
yeah, but this was the longest I'd ever gotten it to overhang. I got maybe 2 or 3 circles before, and then this time I got like, what was it,
6.
6? Yeah,
Here, let me switch over.
you can transition.
Because it's put us in a
Oh yeah,
spot. Okay,
get us into Kira.
and get rid of this.
Yeah, rectangles. I think this could be turned into rectangles, but you'd have to start from a circular shape and then slowly like, uh, yeah, I don't know, warp your way into a rectangle. So you'd have to have the central part as a circle, but then as it gets larger, it sort of becomes more boxy until it becomes a rectangle.
Oh, I missed this one from Al. Design the Eiffel Tower using those settings. Like
Oh,
a design challenge. That'd be crazy. What like it should be a mix of all of these techniques. And actually, the last technique Steven's going to show you is would
that
be really good for Eiffel Tower.
would be, yes. Yeah, because a wire printed Eiffel Tower might be interesting. It's kind of what I'm going to show later. Um, but yeah, let's check out Kira. So I'm going to slice this model using the settings um, that I came up with here. And oh, actually, before I do that, check out this STL file. I actually had to model in these lines in the CAD program to get it to do it
Oh,
properly.
interesting.
So these lines aren't
Do
the
they go
G-code lines. These are built into the STL.
do they go all the way through, or is it just for one layer?
No, it's just for the stuff you can see. So
Okay.
it's completely solid on the inside.
Hmm.
Um, but I had to model in these lines because Cura wouldn't, no matter how I tried, it wouldn't let me get the concentric to work properly.
Yeah, Cura's concentric, like how they calculate it is kind of strange. I find it's difficult to get it to do what you want.
Yeah, because Cura's would follow the curve of the first disc
Hmm.
and it would make like a half moon shape, but I didn't want that.
Hmm.
So I'll show the preview and I'll maybe go from above here.
So this is point 0.5 line width, but it was still printed on a point 0.8 nozzle.
Yeah, so the line width, yeah, it's 0.4, printed on a point
Oh, so,
8 knot. It's actually 0.39 because reasons. It just didn't work with point 4 or something. But this is okay, this is the important part, right? So this is where it's filling in a top surface. Here we go. So can I just play this? So this is where it's actually doing the bridging over nothing. And you can see it sort of loops back on itself every single time. So there's always something to, I guess, support the print that's getting printed. So it's almost using this tension idea where if you print a line and you print a line right next to it, like as a slightly larger circle, then it will hug it and sort of they'll support each other in a really cool way. And so this kind of just keeps on going, and I found I could get all the way to about here before stuff started going really poor.
so it's like the disc is about 4 centimeters in diameter.
Yeah, yeah.
That's
And
pretty crazy.
that's kind of like the limit because it would actually sort of warp up near this end. So if I kept on going, it would warp up so much that that the print would catch on it and the whole thing would fall off.
We need something that can like calculate the actual tension you're getting. Because what
Hmm.
I think you found here is some like nice set of settings that works for that range. But
Yeah,
I'm sure you could go way further if you like dynamically changed
yeah. So it could be
speed
that
and extrusion rate.
yeah, because the settings I use might be really good for this middle part, not so good for this inside bit, and not so good for this edge.
Yeah.
So if there could be some sort of dynamic adjustment, that'd be really cool. But in general, I think the print settings that I had to figure out were the Z seam on this was incredibly difficult to get right. It has to be sharpest corner, And for whatever reason, Cura creates these really sharp corners right here, which is really nice. But if you set it to anything else, it'll completely fail.
Yeah, why don't you show what you mean by that?
So I'll slice it using the shortest setting. And so this would fail. It looks pretty good. But this would fail, well, immediately because it's starting for some reason right here. This is the first loop. So there's nothing on the inside to support it. So it's just gonna droop. And then it comes and fills in the middle.
Yeah, that doesn't, yeah.
And for some reason it does some weird stuff over here. So
it's like skipping lines randomly, yeah.
Yeah, so shortest didn't work. I had some really weird user specified settings I tried. I think this kind of worked.
Was it, so you're like in this one, you're just pulling the origin way off the build plate?
Oh, in this one, I told it to go as far back as possible.
Yeah.
So it's trying to start the layers over here. But
you'd have to do it at like
it really messes it up. It doesn't know what to do.
Negative infinity for it to work.
Yeah, maybe negative infinity would work. I don't know if Cura accepts infinity or ZSeam.
Cura doesn't even accept normal numbers sometimes.
Yeah.
You should check if anyone's got any questions or comments.
Yeah, true. Oh yeah, line spacing like Super Slicer.
Is it anyone out?
Cura has a line width.
It does have line space. Because it's like extrusion width and line width, right? Because you can
so like line width, I believe, is line spacing.
Yeah.
Let me know if it's not.
I think it is. Because we've used it to do like that fake ironing effect.
Yeah.
Where you do use a 0.8 nozzle to do 0.4.
Oh yeah, the top surface skin.
Yeah.
That works.
Isn't that called line width? Or is it called line spacing in Cura too?
I think line width is just the width of the line, and then the line spacing is almost always equal to the width of the line because you wouldn't want it to have gaps.
Is it called line spacing in Cura? That's what I mean.
Oh, I believe. Well, we can see. So we can search up spacing.
I've only ever seen it as I've only ever used it in the top skin settings.
Yeah, so we have a top surface skin layer.
Under experimental.
If I set it to 1, it'll show.
Top surface
so it says line width. So maybe Super Slicer has something that Cura doesn't, or maybe we just call it the same thing, different names.
I think in Cura it's like you can do line width and then you change your extrusion multiplier. So you can do like
yeah, that would work.
Yeah, I think that's how you.
Because you could under extrude on a thick line, and then you'd get gaps in between.
Yeah, I think that's how I've messed around with it in the past.
We got a question from Henry. Does it work better or worse with less than a 0.8? And the unfortunate answer to that is I don't know. I only use a 0.8 nozzle, so I don't know if it'll work on a 0.4. I imagine it might. I just figured it should work better on a 0.8 for some reason, because if it's trying to extrude a really thin line and then there's like extra space around it, it might help it fuse to other stuff. But to be honest, I don't know. I should try it. Try turning on monotonic. So in this case, I don't think monotonic will do anything because that only works on top surfaces.
What's monotonic?
It makes top surfaces print with all the lines being printed in the same direction.
Oh.
So it actually, I'll switch over quickly to this. I could have used monotonic to fix the surface quality on this. So this didn't have monotonic lines. You can see it. You can see these like weird artifacts because of the nozzle not moving in the right direction. I'm still getting used to this camera.
I put it on fixed focus, so it'll always be the same.
Yeah. Yeah. So monotonic would have fixed that.
Is that something they recently added?
It is, yeah. It was in, I think, Cura 1.12, 4.12.
I don't think I've ever used it.
It's really useful. actually always keep it on now. It's never. I think the only reason you wouldn't want to use it is if you want to like save 1% on your print time, because it'll sometimes just do an unnecessary travel move
Yeah.
in some cases. But
The 1% is a small price to pay versus like throwing out an ugly print.
yeah, so yeah, but these lines are red, so that means that they're outer walls. So monotonic wouldn't affect the order that they're printed.
I see.
And since this is concentric, I don't think monotonic even works on concentric. Maybe it does.
You're literally printing in all directions with
Yeah.
a concentric.
Yeah. Line width is the width of the extrusion. Line spacing is the distance between lines. Yeah.
I think Cura doesn't have line spacing.
Yeah, I think because Cura is meant to get, I guess, good prints, and I don't know why you would ever want a line spacing that's not the same as your line width, because that means you'll have gaps or you'll have squished lines.
Yeah. Well, I think instead of it's
It would be nice to have that control though.
It's more intuitive than what you have to do in Cura.
Yeah, well, yeah, with Cura you can only control line width.
Because like, well, you can do line width, and then to get the under or
yeah.
over, you have
Flow
to do
rate.
flow rate, which I find less intuitive than line spacing and line width.
Yeah, no, I agree on that.
Super Slicer has monotonic only on visible surfaces, or you can set on all there. Yeah, I think Cura does that too. They call it like it's in the skin settings, right?
I've never really used anything other than Cura to much
No, like
extent.
I'm saying Cura's visible surfaces are all called skin.
Oh, yes.
So
Yeah.
you would, yeah, just different terms for the same stuff. I feel like over the last maybe 2 or 3 years, slicers have actually all kind of started converging. I know Cura spent a lot of time, like over the last couple of years, just basically bringing in a lot of the really nice features that Prusa Slicer and Super Slicer had.
Yeah. I actually requested monotonic on GitHub.
They heard you.
They did. They responded to my thing,
Oh,
but
cool.
I was asking along with other people, so it wasn't just me.
Yeah.
But hope maybe I made them push it out sooner than later. But yeah, this was the overhang.
Mm-hmm.
So if any of you guys want to, get this 3MF file to try out for yourself, hit me up on Discord. I'll send it to you. Be really interesting if you guys want to try printing in like different nozzle sizes or different materials. Trying to refine this even further to get like perfectly clean overhangs. It could be a really fun project.
Okay, so that was cursed bridging.
Cursed bridging, yes. Not allowed to print without support unless you're doing it on purpose.
Should we show this is the last one, right?
Yeah, so the last one is we've graduated from Cura.
So say goodbye to Cura.
Yeah.
We're going to be showing you true non-planar printing.
Yeah. So I'm gonna do a quick little demo. So I didn't actually bring my super non-planar print because I forgot it, but I have this I have this custom print that I made using full control G-code. So this is a print that you basically can't do with Cura. And I made this over, I guess, the course of a week. So it took a really long time to figure this out. But this is called string art in a way. So this sort of idea of creating like mathematical lines across objects, sort of connecting them in a pattern. It's called string art. And so this was entirely custom coded. So I didn't use Cura to make this at all. And my running name for this is Hex Web. So it's a web of hexagons, I think it works. And I'll show you the underside of it too, because the underside is even better. Let me see.
There's some thick extrusion lines.
Yeah, check out those extrusions. Anyone who likes those thick first layers.
So what are we looking at? What is the line width on this? And actually, I'm noticing, do they overlap or Does it actually stop and break like at the correct point then?
Nope, they just go straight through.
Oh, I see.
It's yeah, it's a lot of effort to code stuff like that in. So yeah, like right in the center here, the lines just cross.
Over one another.
They just overlap. Yeah.
What is the line width?
First layer, it's 1.2 millimeters, but with a 3x multiplier, so
Okay.
it's about 3
That's
millimeters,
crazy.
3.6 millimeter line width,
Out of what size nozzle?
0.8.
Yeah.
It's actually a 0.8 volcano nozzle,
Okay.
which I'll talk about later because I put it onto a V6 hot end, which is also super illegal. You're supposed to put a volcano nozzle in a volcano hot end.
Cursed like nozzle.
It was for a very good
Printing.
reason.
Yeah.
E3D did not allow me to do this. Like, please don't use the wrong nozzle on the wrong hot
Yeah.
end, but I did.
Don't tell E3D.
No, yeah, E3D can't know about
Yeah,
this.
it's an illegal activity.
Yeah,
Shall we cut to the back to the Google Drive?
yeah.
or-
So let's go to the Google Drive, or the photo album, and I'll sort of show you guys how this idea evolved. So, um,
We got a request to make a hatching dragon.
we need a hatching dragon.
We could use those eggs.
Well, yeah, we could do the eggs, right? And then, I don't know, could I do it right now?
What do you mean?
We have a dragon. We have an egg.
Oh, I see.
This is
That's
the classic dragon. Okay. Danica, this is the request. Give me a sec. I think this is the coolest egg. So, hatching dragon. Here we go. Ready?
Wow. we can send Danica one of these.
Yeah, we can. Yeah. So we printed a dragon. This is not illegal. It's perfectly legal.
Legal print.
Yeah. You're not getting in trouble if you print this. Just don't sell it for profit.
Can you? I've seen people doing
I
it.
think you need a license from the designer.
Yeah, that makes sense. I think Steven has too much time on his hands.
Yeah, I have enough time on my hands to do this stuff. You do too.
Yeah. I tried learning full control was it last weekend or the weekend before, and it's very complicated.
Yeah, it is a lot to get through. The learning curve is pretty harsh. Like it took a long time for me to even get.
You said
My first
1
print.
week for the first one, right?
Yeah, so this is my first print that I was proud of that I made using full control. Just gonna make sure that's showing up.
It is, yeah.
Yeah. So this I posted it on my Instagram as well, and I shared it with the designer of full control cheat code, the guy who
I've
developed
seen
it.
it on his website, I think.
Yeah, so he posted it on his own Instagram and thought it was really cool. So I was quite happy with that. But this is my flat version of what I'm calling the Hex Web, and it's just a single cell. So the one I just showed you on the B cam there was 6 or I guess 7 in a pattern, and but yeah, so that's I guess the first iteration, and then it turned into this second iteration, which I was just showing, but here's it with right off the printer. So all the stringy little bits are still there. This huge prime line is still stuck onto it.
5 millimeter extrusion.
It's ridiculously
It's
huge.
insane.
But I'm allowed to do whatever I want because
Yeah.
it's full control. So
That's true.
now, okay, let's go here. So this is what it looks like when it's printing. If it will let me do it.
There it is.
Can I do
Oh, wait, let's change the settings.
garbage settings?
Oh, maybe not.
Oh, I didn't upload. Okay, well, see if I can get a different view. Oh man, these are gonna be bad quality videos.
Google didn't. We can post them on Discord later.
Yeah. So this one is doing non-planar printing. It's really hard to see though because it's so
You can see the
blurry.
nozzle moving up and down.
Yeah, the nozzle is moving up and down.
Should I be pointing at the screen or should I be pointing like this?
Okay, let's just
Oh,
let's
this
go to
one's
here.
good. This one's good.
Yeah. So here's just an intro. I haven't fully explained what non-planar really is. yet, but um, this is how it printed the next version. So this is the non-planar version of the Hex Web. So as you can see, these lines are, they're not actually squished together like in the previous version. They're all separate. And that was very intentional because I thought it would look cooler if they were all non-planar.
So they don't really touch each other too much.
They don't touch each other because the z-axis is moving up. So if you can see here, the nozzle isn't moving in straight lines or on the same z-axis position.
I don't even want to begin to think about how retraction works on this hot end.
Yeah. Oh, yeah. So, okay, if we're going to talk about the hot end, this is the illegal trick that I did. I put a volcano nozzle on a normal V6 nozzle so that I could extend the nozzle further down because since it's moving up and down, it's going to crash into stuff um, unless the nozzle is extended. So, yeah, I had to put an extendo nozzle. You can see the threads on it.
Send them nozzle. Yeah.
Um,
Illegal. The illegal V6.
Here's an even better view of the illegal hot end.
Yeah, so just moving up and down.
Yeah,
I like owls that make a really cool clock.
it would make a
Imagine
cool
if we
clock.
printed a big one on like the CR10.
Yeah, I should do one on the CR10 actually.
Yeah.
How much hotter do you have to print to make up for the volcano in a V6? I print this at 240 degrees, and I think by the time it comes out of the nozzle, maybe it's only like 220.
I'm impressed that because the layer fan is blowing right onto
It
the
is.
console.
The layer
Like,
fan is doing nothing really.
how does that not just screw up the thermals completely?
I don't know, but it would do thermal runaway without the sock, if that helps. So the sock was required.
Like I would just expect the filament to freeze with the layer fan blasted.
Yeah. So here's the finished print. So this, I could maybe do this one and then the other one, but this is using non-planar
Do you do a side-on view?
I should do,
Oh yeah, there it is.
kind of.
So you can see how it's like pointy.
Yeah, so there's like depth to this now. You can kind of see inside these little webs.
So first it prints the structure and then it prints the webs on top of the structure last.
Yeah.
Okay.
So
Oh,
it
that's
prints.
a good photo.
Yeah. This is probably a decent view.
Oh, we got Ben in chat.
Hello, Ben.
You joined for the best part, the most forbidden. This is actual 3D printing and using all three dimensions at once.
Yes. Yeah, we're doing true non-planar 3D print, as Al says. So this is not from Cura, this is from full control G-code. The z-axis is moving up and down when it prints this stuff. Here's a really cool view of the bottom, showing the depth you can get with the non-planar stuff. So
I like Al's suggestion, a skeletal version of an aircraft wing being printed. That'd be interesting. Like I see this
That would
being
be pretty cool.
really good for if you wanted to print like a structure or scaffold or something and then wrap it
yeah,
with something else.
yeah. So these are actually very like sturdy.
Mhm.
Like having so many strings in a print, it's, like even when it gets bigger, like this whole structure is actually very sturdy. So you could actually probably get away with using this to maybe create, yeah, like a skeleton version of like aircraft wings or like building structures or rockets.
I'm just thinking about maybe even like for packaging or something. Because you would be using so much less material. Like you don't need solid walls to you know how we use corrugation to provide structure to our packaging, but imagine some kind of structured fill that would print lines occasionally within
Yeah,
a perimeter. I mean, I
that would
think
save a lot of material probably,
I
right?
think so, but I also think like our corrugation is already really efficient. But you know, there could be other shapes that would benefit from something like this that you can't corrugate the outside of.
Mm, yeah. Yeah, so you could strengthen prints with little strings
Yeah,
and also save material.
like keep. I'm thinking of where the envelope needs to be a certain shape, like you can't
Hmm.
corrugate it, but then you could add some kind of internal structure to prevent it from flexing in certain directions.
Right.
Like
Yeah.
remember how floppy the straight line, like if you print a square
Yeah.
that's got no top and no
Oh
bottom.
yeah, it'll just
Yeah, but if you added
flex
something
around.
like that inside, you could maybe prevent certain types of flex from happening.
Yeah, you could. Yeah, because it would basically act like a rope, so it would
Yeah,
prevent stretching until it breaks, I guess. But
yeah.
just don't stretch
I
it that
guess
far.
that's kind of what support for like internal infill does.
Yeah. So right now I'm showing kind of a G-code preview of the non-planar print, so you can see how it gets more. Um, so the layers are not flat anymore. You can see that they get um,
They kind of bend down
yeah,
and
they bend
then
up, right? So I guess if I just stop it right here, these layers are definitely not flat. So they start off really thick and then they get smaller or they go lower and lower and lower. And actually, as they go lower, I also had to adjust the extrusion width or flow rate so it didn't get super over extruded.
I'm just gonna ask about that.
Yeah, so it's actually it's kind of nice that the layer height is a linear decrease down to zero, and then also the flow rate is a linear increase down to zero. Um,
Hmm.
and you have to do it in a very
Is
particular way.
is flow rate and layer height like is it a linear relationship?
Yes.
Yeah,
Yeah, so
that
if
makes
you
sense.
double, well, line width and layer height and flow rate are all kind of
Yeah,
related. Uh,
but this is constant line width, right?
so, and I guess if we're talking that, yeah, the line width is constant, uh, the extrusion multiplier is constant, uh, but the layer height itself is shrinking, and full control knows that when the layer height shrinks, the extrusion has to also
Okay,
shrink.
so oh, that's a,
So some of this stuff is automatic. I didn't calculate all of this
you
by
didn't
hand.
have to do that. Okay.
Yeah, so I just told the layer height to shrink and also told the Z to go from this high part to this low part.
And it calculated the extrusion multiplier difference
Yeah,
as
so just
well.
to give you an idea of, can I just like refresh this? Just to give you an idea of what full control G code actually looks like. This is what I use to program this model. So
So there's no STL for this.
this is the source code for, yeah, there's no STL. So these lines are all
This is
full control G code.
so it's straight from like it's a G code designer as it says on the box.
Yeah,
You're working straight into G code. There's no how do you visualize it when you're working on it?
that's a good question. So you can visualize it using a program called Repetier Host. You cannot use Cura. Cura really doesn't like non-planar.
Okay.
It actually just completely breaks and looks like really weird. I might show it later, but um, let's see if I can just transition to Repetier Host. So this is Repetier Host. It's kind of it's been around for a while, and it's what some people use for a print server. But it's got this really nice feature where you can see G code, and it'll actually draw every single line of G code, and you can kind of scroll through your whole print, and it doesn't care if your lines are planar or non-planar. So this is a large version of that Hex Web that I showed earlier, and I'm just going to show a little, like just a few features of it. So um, here's one area where the lines start off really thick, and you can see right here they're all thick lines. And if we go over here, they all squish together. So there's still lines being printed, but they get really, really squished.
It's still the same number.
Still the same number of lines. They just go really, really thin to the point where I can't even zoom in any further. Um, yeah,
Does does Repetier Host do extrusion width too, or is it just visualizing the lines of G code?
it does do extrusion width. You can see the first layer here is super thick,
Hmm.
and it knows that it's super thick because there's just a ton of material being extruded,
Hmm.
and so it calculates how thick lines should be. And this is the really thick prime line.
Yeah, it almost helps that it's like a bit of a more basic visualization.
Yeah, so this is how I debug stuff and how I kind of get a preview of what I'm actually working on. Because you can't just program the whole thing in Excel and expect it to work. You have to kind of just keep on going back to this repetier and checking it. So um, this is the first, I guess, line of the hexagon web pattern, and you can see it just keeps on growing from here. And I guess at this point you can start to see that it's now no longer planar. It's getting into this sort of mountain-looking shape. And this is all done to make a print that looks really cool. There's no other reason than I thought this would look pretty cool,
Yeah,
so I
I'm
wanted to do
sure
it.
there are lots of practical applications. Like I'm thinking of a few, but
We can talk, there are practical applications to full control. Yes.
yeah,
I think
just
it's easier to get started by doing cool looking math things and then
yeah, you have to
figuring
learn it
out
for sure.
like real life applications for it.
Hmm.
But this is just a continuation of my very first full control G-code project, and this is kind of what it turned into. Um, but we can show what full control itself um, has come up with as some applications for non-planar or just very high control G-code.
I think a big one in general is just that it allows you to actually take full advantage of 3D printing as a like manufacturing technique because you know if you're just using your printer as something that does two-dimensional drawings stacked on top of one another, like you can already do
Mm-hmm.
really amazing things with that, but as you show, maybe you show Ben the overhangs, but like once you have more direct control over your design and how the machine moves, um, you can make parts that use less material and parts that are stronger. Here, I'll just show.
Yeah, so one thing you can really do with full control is get super optimized print. So there's only lines where you want there to be lines.
Show Ben the
Um,
overhang because
yeah,
he came in, or anyone that's come a little bit late.
yeah. So here's an example of a print that was done to create like overhangs without support material.
Hmm.
So if you can see this, this was not printed using support material.
Yeah, so it's
There's the overhang.
not using full control, but it's definitely getting into the realm of you know very specifically building G code um, to take advantage of 3D printing.
Yeah, and actually this would be a very simple shape to make with full control. And I've actually started trying to make this, recreate it in full control.
Hmm.
Um, but for now, I got kind of tired. This is like the 50th or whatever
Yeah,
iteration of this thing.
I
So
can just imagine for as stuff becomes more and more automated, even on our systems, I'm thinking about how can we save material in our designs, um, get better designs, but not like better designs, but not at the cost of using support material. Like
mhm.
whenever you have to turn to support material, it's just a big time sink and a big material sink for like material that's completely wasted beyond that one print. And
Yeah.
as we found with automation, like support material doesn't scale well. Um,
No, because then you have to remove it.
yeah, you have to remove it, and you're throwing away so much material, so it becomes really wasteful too. So that's why, like, to me, this is so interesting to see, like, okay, not only can you get parts like this out of a printer, but you can, because we have automated printers now, you can actually do them at scale and do stuff like this at scale. And it also justifies spending more time designing those parts too. Like
Yeah.
if you're spending like a week designing a part and you're only ever going to be able to produce 10 a week, that time investment doesn't really make too much sense for
Hmm.
production. But if you spend a week designing a part and then you have the capability to produce hundreds of thousands of them per year, then it makes more sense to be spending that time in the design phase. So it's definitely like moving out of just how do I get a fast prototype, a fast design put together and printed to like, let's invest time into designing better products.
Yeah. Yeah, so you can really optimize like that last maybe 10-20% on your prints because Cura works, but you're not going to get fully optimal prints. Like you might have balls where you don't need them. You don't have, might not need top surfaces everywhere. Um, yeah, like having the full control that you get with full control G-code, it's a really good name.
Yeah.
Lets you do like really nice optimization.
But even as you've shown, like even just in regular slicers, like if you get a little bit creative with your modeling, you can um, still take advantage of a lot of like non-traditional ways of printing. Um, yeah,
Yeah,
I think the other thing that is cool is again going back to the automation is because you don't have to spend so much time managing your printer, you can actually you now have that time to mess around with things like full control or mess around with things like very specific part design so that you can get better products out of your machine without having to worry about then like dealing with the actual production of them.
yeah, yeah. Like having the ability to do whatever you want with G-code is really cool.
Yeah.
Al says, "Thanks, guys. Like my days are filled enough. Now I want to learn and play with full control. Just what I need."
Yeah, it's definitely like I'd be curious out to see whether there's something in there that you could apply to the products that you're printing. And I mean, it'd be really cool to be able to see products like this. Yeah, sure, designed that way, on a mass scale or being sold beyond just like some cool prototypes, some cool math shades.
Yeah, if you any of you guys want to learn full control, it's you just go to fullcontrolgcode.com and the guy who made full control also made a whole bunch of tutorials. And I watched all of these. It's about 2 hours to get through all of them. But by the end of it, you can do pretty much everything. He covers all the controls, all the commands in the program, and pretty much all the advanced options too. There's some stuff you have to figure out for yourself, but um, you can contact him. He has a subreddit, Full Control. Um, but yeah, I highly recommend playing with this software because it's super powerful, and I don't think I've even touched I've only scratched the surface of what you can really do with it.
Yeah, I'm pretty excited to see how we could try and start applying some of these design ideas to like actual products that we're making.
Yeah, so this is, I guess, an application for a mesh, and this is I guess a normal grid. I think he's changed his G code though in this one to make the mesh different. So you can see it's speeding up and slowing down, and it's turning into like a gradient. Um, I think this one looks really cool. It's like a circular gradient.
Yeah.
So you can get really interesting effects using three-dimensional, or I guess in this case it's just a 2D um, variation in extrusion width, and it's really hard to do this in Cura, or impossible to do this in Cura. Um,
Yeah, and this is like something you would never expect to be manufacturable with 3D printers. Like
yeah,
people usually die cut meshes or laser cut them, like meshes, custom size meshes. Like it's very difficult and expensive to manufacture these.
hmm
But having something like this tool and then couple it with how inexpensive, automated 3D printing is, you now have an avenue to just mass produce really like custom designs like this.
yeah. Like this probably wouldn't take more than 20 minutes to print,
Yeah.
maybe even 5 minutes or something.
And you
And
can
you could
print,
pump out hundreds of these per day.
you could do like a run with a whole bunch of different variations. And then immediately once you find the one you like, send the job to your print farm and then queue up like 1,000 of them in Quinley and start producing them instantly.
Yeah, yeah. So there's a lot of potential with this idea.
I
I'll show
really
you
want to
exactly
like
another way that you can use sort of full control G code. This is a retraction test I did, but it covers 120 different combinations retraction speed and retraction distance. And I was trying to get these strings to be as clean as possible. And this was much easier to do using full control G-code than any other test print. The video didn't really work too well there, but
yeah, not sure what's going on.
Al says, these prints and my excellent designs, thank you, are further proof non-planar printing is around the corner for all of us, limited only by the current software, not necessarily by the machines we own. That's totally true.
I think that's true as well. I think, like, I'm excited to see non-planar things to be people starting to design non-planar things, and then yeah, I can't wait to see people put it on Quinley and just start like mass producing and like putting it in real products. I think it'll be really, really cool.
Yeah, so this is just an update from Full Control. The guy's working on an actual program, so it's not just going to be like an Excel thing that you can play around with. It's going to be based on Python and have a much more intuitive feel to it. So I'm a beta tester for it. Haven't tried it yet, but when it's ready for beta testing, I'll let you know. But let you guys know how it is. I'm looking forward to it.
Yeah, I'd love to be able to do some of our Quinley parts. I don't know.
Yeah,
how we would.
Like a packaging could be a good one.
Yeah, or even just like for aesthetic purposes too.
Yeah,
maybe. Yeah.
Yeah, we have some more, I guess, close-up shots of. This was a really rough version of the web, but I made it super obvious how the non-planar worked. You can see there's some really gnarly stuff going on with the nozzle.
Yeah.
But forget about that. Don't worry about it. It's fine.
It's a good demo though.
Yeah, so you can see how the nozzle is like literally going up the mountain and then coming back down. So that's why, we call it full 3D non-planar. The z-axis is totally moving at all points in the print, basically.
Yeah, and going back to Al's point, this is all done on an Ender 3 with the Quinley upgrade.
Yeah.
Right? So if you wanted to, you could just start pumping out like hundreds of these tomorrow.
One thing I want to do is actually print a wall of these and kind of make a tiled design.
Even the background maybe.
Oh, we could.
Yeah.
Oh, maybe I'll do that. I could run like 100 in like rainbow or something.
Yeah. That would actually be so cool. It would probably help with the sound in this room too. There's an application, sound editing.
Yeah.
Like you've seen those like live walls that they make out of crazy wood designs.
I wonder if that would work. Sound dampening, like.
I think it would.
Damping, I guess, is the better way to say it. But yeah,
We
sound damping prints.
Need some for our background.
So here's some just really, I guess, macro shots of. I just really like that there's a lot going on here, but you can really see the non-planarness of these lines. So how they go.
These layers are crazy.
Get really thin on this side and how they get really thin on this side. There's a lot of weird over extrusion artifacts going on over here and some definite retraction problems. Z-hop and retraction are really weird to do in Full Control. So that's kind of why it looks so weird here. It's like after a Z-hop, it retracts and then does a Z-hop. That's in the wrong order, but.
Oh, I see.
Yeah, like it squirts out the filament and then it moves down and then it starts moving. So it's like the wrong order, but
yeah.
I could probably change it if I knew slightly more, but.
Oh, else is too hard of a surface or
too hard of a surface.
But if it was loose strings, like because those overlapping strings are not really solid, are they? Like,
no, you could if you make them really long,
yeah.
Then they would just be like maybe you're like they could actually absorb sound energy.
Mm-hmm.
Or we could do like literal strings, so do like a 10% flow, because that can work. Full Control guy has done another example about intentionally stringing with like really thin strings to create like flow restrictions in pipes and stuff.
Oh, got it. That's interesting.
So here's some more interesting pictures. There's a lot of buildup that I tuned that out using the retraction test I showed earlier. but this is what it looked like before I fixed the over extrusion retraction weirdness. Turns out just retracting 0.5 millimeters on that volcano nozzle is the best.
It sounds more like that was a hot end settings problem.
Yeah. This was some really weird stuff. I love this stuff. I don't know if you guys like seeing weird 3D printed artifact defect stuff, but I think it's really cool. I guess this is the clearest picture of full control.
Yeah, the
non-planar.
Non-planar layers. Cool.
Yeah.
Yeah, this is so cool. Yeah, I'm just thinking, how do we incorporate some of these design elements?
I wonder if I can find out his he did an example where he did intentional stringing. This guy. Yeah.
Mm-hmm.
So he made these can I find it?
Yeah.
Yeah, these. So this, I guess, in slide A, he did a retraction test or a stringing test to find out, I guess, the best settings for getting these really thin strings. And then in slide B, you can see he's applied it on this hexagon shape to create. I don't actually know what it is, but I think it's a flow restriction thing for maybe fluids. He talks about these more, and he wrote a whole article about it, or like a paper on it.
Yeah. It kind of reminds me of that when we were designing the FDM swabs. Remember how we had the stringing internally?
Yeah, that was using Cura hacks that they didn't want me to do.
The rough, like, yeah.
Using like infill printed at really low flow rate to get strings. This is an example of using full control to optimize G-code. So he did this for the COVID face shields, which we kind of also did. We designed our own face shields that were optimized.
We did it in CAD as much as we could.
Yeah. But I guess using full control, you can really get perfect
like this
optimizations.
Yeah.
So in this case, if you wanted to print thousands of face shields, you would invest, probably 2 or 3, maybe 4 hours to design this in CAD, but then it would use like 20% less material. It would print 5-10 minutes faster. It'd be really useful for optimizing your prints if you're printing a lot.
Yeah, and what we found, even just optimizing our CAD file, we were able to cut down the print time of the face shields. Well, it's like from 75 minutes to 35 minutes.
Yeah, I think so.
Yeah, it was like
more than half, or about half.
Yeah, and so then with this would just be one step further, which again makes such a difference with mass production. Not so much. I mean, this is an application where he's mass producing these. Because even if you're printing 100 a day, even just like a 10% savings means you're now printing 110 a day.
Yeah.
Roughly.
Yeah, for free.
For free.
Yeah, it's like that stuff pays its off over time.
Yeah. Well, for like the extra couple hours you spent, but that goes to zero with the more stuff you're printing.
Yeah. So I got a question from Ben. Did you use the volcano nozzle in order to obtain more clearance for the z-axis? Yes, exactly. I'll see if I can show
the purple video.
Yeah, this one is probably the best demonstration. Because I tried it without the volcano, and it kind of worked for really shallow non-planar, to the point where you didn't even really realize that it was doing anything non-planar. And I've ordered a super volcano nozzle to see if I can do like really insane stuff like 45-degree angles and stuff.
I'm wondering if the Pico hot end would be good for this stuff, because that was something I was looking at it for.
Oh, because it's such a thin form factor.
The whole thing is really thin, and the nozzle was really maybe Google it, see if
hot end.
Yeah, I think they have a really pointy nozzle.
Okay, let's turn this off.
Yeah.
This one, right?
Yeah.
Oh yeah, that's super skinny. Wow, that's tiny.
Yeah, it is really thin. I guess the angle is not that good though.
Well, it looks like max you can do is like 30 degrees on this
Yeah.
one. I know there's a site. I think it's like, let's see, I think it's like, yeah, XYZ printing. Um,
Oh yeah, they've got.
I don't know if I can find the right one. There's a non-planar nozzle. Oh yeah, non-planar.xyz. These guys sell super long nozzles that do uh, non-planar.
Mm-hmm.
Um, but these guys only fit in the Ender 3
Oh,
hot end.
what?
So they don't
What
sell
is that?
E3D.
M6 or something?
Yeah. So if you have an Ender 3 without any modified hot ends, I mean, these would work great. But I had an E3D nozzle and none of these would fit. So I just got a
Oh
Volcano,
no.
which is fine because I think the Volcano is cheaper than these guys. But um, yeah, you can
That's
get
too bad.
hardened steel. I think they come with like this silicone
Maybe we need to go to the
insulation.
machine shop and just machine down a super volcano.
Yes, because I still want it to be pointier.
Because there's a lathe there
Yeah,
that
I should do
we
that.
can use. Yeah.
I'll come with you next time. Do that
I have
when I
to
get
go
it.
tonight, but I'll email David.
Okay, so
I think we've covered it all.
yeah, super volcano nozzle on a volcano hot end. Now that would be probably a good idea
Yeah.
because otherwise there'd be a lot of stuff hanging out. I think
Yeah.
the super volcano is actually way too long. Like, if you just search up what a super volcano nozzle actually looks like, it's ridiculous. Like that is a huge nozzle. So I think that would be way too long for what I need. So I'd actually chop it in half probably, um, and sharpen the tip in a lathe. I have files at home. I was imagining I would just file it down manually, but a lathe would be
Like
enough.
with a drill and hold the file to it.
That would probably be the
That's
best
a
way.
type of lathe.
Fake lathe,
Yeah.
illegal lathe
Illegal
hacks.
lathe for illegal printing.
Yeah, so I'll send
A
updates when I do
lathe
that.
would probably be better because you'll if you file it you'll curve, like you'll mess up the hole.
Yeah, I'm gonna try to avoid the hole
It
itself,
needs to be
but
really sharp.
yeah, the hole has to have maybe like yeah, like nothing on the edge of it.
Yeah. Henry Singer MK8 style.
Oh yeah, you could also rethread it for a volcano. That's true.
Is it thick enough though?
Oh, good point.
No, I don't
I don't
think
know
so.
which
Because
one's thicker, right? This one's
these are
M5, or is it the other way around?
I don't remember.
I have a feeling this thread is M5, but
I think this thread is bigger than the Ender 3 thread.
huh. Yeah, okay, well, maybe the other way would work then if you want to make your own Ender 3 nozzle from the volcano, that could work.
Yeah. Hmm.
By the way, if you guys want to see more of my stuff, I've got an Instagram, Layer Shift 3D. I'll follow you back. Yeah, but oh, actually, I should show this one because this is probably the cleanest print that I've done with full control G-code.
Make sure we're showing it actually. Just double check.
Does that work?
Yeah. We're good.
Yeah. And this is the designer from Full Control. He's got an Instagram too. Actually, no, let's check it out. There's a lot of interesting use cases that people have showed. We're really good at this stuff as well. Check out this. Like, how do you even do that? Like, that is just really cool. I don't even know what this is, but look at that line length. So this is some stuff that I haven't even gotten into yet, like changing, like doing this whole wave pattern on your extrusion. Really cool. Stuff like this, where you're doing really obvious non-planar prints. Oh, and that's cool. So the frequency is changing as well as it goes up.
Mm-hmm.
Um, just insane mathematical shapes. Like you can't do that in vase mode with Cura. It won't allow you. It'll just break. It'll give
Yeah.
up.
Yeah, I'm just thinking about all the ways you can like how much this will speed up printing.
Oh, that's beautiful.
It reminds me, it's like the cardioid
Yeah,
going
I
through
think it
different
is.
degrees of whatever that.
Because that's something you can do. You can set like parametric functions so that some parameter will change a little bit each layer.
I bet that the guy who designed the Sierpinski triangle, the pyramid,
Yeah.
wished he had this program.
Oh, probably.
Because it's
I think did he do it in OpenSCAD maybe?
well, I know what he did was it was a Hilbert curve, and then the degree of the curve changed as the z increased.
Oh
So
yeah.
it goes from whatever it was to 0 or 1 or whatever our point was.
Yeah.
Could non-planar, that's a good question. Could non-planar help mechanical properties by making the layer direction
Oh yeah.
variable?
Definitely. Yeah.
Yeah.
Like we said the same thing at the same
Yeah.
time. That was good. But yeah, actually, like, well, check this out.
Said cheese.
It looks like cheese, but I think this sort of overlap, I mean, this isn't a non-planar, but this sort of level of overlap could allow you to do really strong walls. Like maybe this is good for house printing or something.
I bet you could do even like as long as you mingle the current layer into the previous layer and the next layer, I think that that would give you a lot
Yeah,
of strength to work with.
if you could almost like have it hop over.
Yeah.
So like this could actually have really good applications in like the 3D printing house industry. Like this specific pattern could make a really strong wall.
Mhm.
Uh,
But I even think just to like, because everyone's always like, oh, I don't want to use 3D printing. It's whatever anisotropic. But I feel like it might be possible to just start getting
yeah,
at that idea.
because there's definitely ways to make print stronger in the z-axis. It's just really hard to do it with current software.
When you're doing planar printing.
Yeah, but if you can actually do that non-planar stuff on purpose, it becomes a lot easier.
Mhm.
This guy's, I like this one because it's similar to mine.
Yeah.
Uses intentional stringing, which is the first illegal technique that we talked about. This looks like wire printing, which is really cool. Um, I think you might be able to do this in Cura.
This was printed flat, he says.
Oh, printed flat and then rolled up.
Yeah.
Hmm. Interesting. Okay. This is probably non-planar. Or this could be just varying extrusion width. Yeah, so it just uses it like blobs on purpose.
Rotation axis for the hot end. That now
Mm.
that's gonna get crazy.
Oh, there's Ender 3. There's a new upgrade that just came out for the Ender 3. I find images of it. It's really new. I don't know if
Yeah,
it'll even show up.
was it an upgrade or was it just the research?
It's a whole thing you can. I think there's a build instructions for on GitHub.
Mm.
I posted it on the Discord. LSD hot end. Oh, that's for like high flow, right? I wonder if Google will give me bad stuff if I search up LSD hot end.
Anyway,
Yeah,
lots of fun stuff that we'll be playing around with.
a lot of potential.
This one I'd like to.
This is really interesting. Just this is illegal because it's intentionally printing spaghetti.
Yeah,
Ramen.
we'll have to like really step up Quinley Vision to not recognize these as faults.
Yeah, Quinley Vision will have to
It'll
really
have to
get
take
better.
G-code input.
Yeah, yeah, it will.
Well, the other thing I've been looking at is like giving it expected result so that it doesn't like give you false positives on stuff. As long as you print one of them.
Oh yeah.
Yeah.
So you print the first object and then you feed that back.
Yeah, you would give it like for this G code, I expect it to look like this. So you'd have like a reference part and
Yeah.
it would, omit things that were too close to the reference.
That's cool. So you could like temporarily train it on a good print,
You would like
or would it just
you would
reference it?
you would tell it like if it sees something more similar to the reference than the fail, ignore it.
Right. Okay.
Yeah, you're kind of telling it like, okay, omit things that are what I expect it to be.
Yeah, so you could feed it a print that looked really weird, uh,
Yeah,
and then it would know that it's supposed to look like that weird. So as long as it's weird in the same way that the
yeah,
reference photo is,
exactly.
then it's good.
Or even like even like you give it an example of a really good part and you say um you say that like you want all your parts to be of this quality or higher, or
Hmm.
like within like similar to this quality, you can do something like that too. That's what I'm looking at right now, is like showing it a reference object.
Yeah, well, that'd be really cool for like quality control, even on parts that are good. If
Yeah,
like overhangs are bad in some cases
Al was saying could,
to the G-code image.
yeah, that's another thing that um there's some research that came out that, but like render the G code in the correct orientation. And so we could take that, render it correctly to the material, like style it correctly, and then compare what you're seeing to the G code. Although that's a bit harder because if you remember at the beginning of the stream, Stephen was causing intentional drooping. Intentional drooping won't show up in your G code.
Yeah,
Um, maybe do you want to cut back to that just to give people an idea of what I'm talking about?
yeah. So I'll go into Cura.
Or go into the video.
Oh, yeah, okay. I'll go back to Chrome. Yeah, so
Sorry,
as
I mean
you,
go to the B cam. Oh yeah,
oh, I guess
no,
well,
you got
this
it.
would work.
Yeah, so like this is not gonna show up. Oh wait, hold on. I just want to make sure everything is correct. Okay, yeah. So could QV not just compare the current print images to the G code image? And this is the reason why. Like the G code for this is not going to look like it's drooping, so you can't rely on the G code to give you an accurate picture of what's going to come out. And now this is an extremely edge case. Like I think this is something we'd be working on.
I would just turn Quinley Vision off for
Yeah,
this
you would
print.
just turn off like spaghetti or something so it
Yeah,
doesn't detect it. But um, it is like the type of thing that I'm thinking about with more normal prints. Like even if you have the G code, what are the limitations of what QV can actually do with that? And I think one of the easiest things to do is to have a system where you can show it like, here's a reference. This is kind of what I want all of my prints to look like. If I'm going to print 100 things, I want all of them to look kind of like this. Because not only does that give you a reference in case there are rough parts of the print that you actually want to keep, but it also helps, it will help the detection be better because it has it's not just looking for faults, but it has a direct reference with which to compare the print to. And so that can be really, um, really useful too. Yeah, there's like a lot of really cool stuff that are cool ideas that I have for how we could show reference objects, how to get rid of the like camera position variables and stuff like that. That's part of
yeah,
what the 3D was for actually.
right. I can see that being very useful for like doing large production runs when it makes sense to specifically train a model on a part so
Yeah,
that it can identify a good part from a bad part, um, for that part in particular, even if it looks like stringy or non-planar.
yeah, definitely. Yeah, there's a lot of stuff like that that I don't want to talk about yet because it's like yeah, it's still a little bit secret, but I'd like to be able to show something when I talk about it. Yeah, he's saying uh, do a bypass for certain detection settings or have a sliding control. Yeah,
Mhm.
that would be like the easiest way to do it, um, which is probably how it will be implemented at first.
Yeah, so on this one, I would still say I'd like to keep no extrusion detection. I want to know if
Right,
there's a nozzle clog,
and excessive stringing
like
too.
layer shift, excessive stringing. maybe would work because stringing is very different from this.
It doesn't detect spaghetti and stringing as the same thing. It can tell the difference, so it would still work.
Yeah.
Only issue with reference images would be image quality, background, etc. Not necessarily. That's so. I don't know if you've seen um, the more recent work that we've done, but this kind of thing where you have 3D representation kind of gets rid of the issue of matching angle and image quality, because you can do a lot with this. You can also get rid of the background. So with the 3D scan, you can see how it's kind of sitting in a black void. You can crop the background out of the scan and then match up your angle to what the camera's seeing and do a comparison. But yeah, I'm not gonna go into that too much right now because I just want to make sure we're even showing it. Yeah, we are. Because yeah, it's kind of far away, and I want to have a visual demo.
It'd be cool to see like even just an example of like the G code being overlaid onto that.
Yeah,
The G code from Rapid Host or Cura or something. It's probably not terribly complicated to
it's
model
hard.
it yourself.
No, it's really hard. It's really tricky.
Uh,
I've looked at it. It is actually like I think I was mentioning last stream, to get all of this stuff working, we need like a team of devs.
yeah, I mean, like when I say it's not hard, it's definitely a lot of work.
In concept, it's not hard.
In concept,
It's easy to
it's
visualize.
yeah, yeah.
But in practice, it's like it's really difficult to do any of that stuff. Yeah, it is like it even just getting this working was really tricky. And this is like
Yeah, well, having it work with Quinley Vision and finding the correct orientation in relation to that,
yeah, it's
and the
tricky.
scale and all that, you have to
It's
figure out calibration.
Yeah, like you'll see it when it zooms out too much, it'll start losing things, and that's just like an issue of scale that um I've tried to train it against that, but yeah, that's why I keep saying like with Quinley Vision it needs, even though we have these cool results already, it's gonna need a lot of work and like um
To
you
reach
know
its full potential, I think.
yeah, and definitely a dev team that's because
It's got more than 24 hours a day.
yeah, like yeah, basically.
Or just a lot of devs. I don't know.
So if you want to get Quinley Vision on your printer, make sure you sign up for this email list and share the email list to other people who you think could benefit from it, because that's the only way we'll be able to get something this cool onto your printer.
Yeah. And when we have something to try, whoever's on the email list will get
They
first
get
dibs.
first dibs, yeah. Which is the real incentive, is you'll be the first to be able to try as soon as we have something portable, I guess, that you can interact with. 'Cause
Yeah.
right now it's like, yeah. Anyway, sign up. Get your friends to sign up. Get all the Discords you're in to sign up. And yeah, maybe I'll work on some demos with it, working with the full control stuff. I think going back to Al's suggestion, like just a simple bypass would definitely get us most of the way there.
Yeah. Ooh, favorite 3D printer.
This guy.
Can I say Ender 3?
I don't know if it's my
It's
favorite.
perfectly good.
We have the most of it.
Yeah.
I think I like.
Do I have like unlimited budget? Hmm. Yeah, I think Ender 3 is probably my favorite. It's
Luca, what's your favorite 3D printer?
just enough, not too much.
The Ender 3, you said?
Yeah, it's like the Jeep of 3D printing, just enough essential parts. I think that's what it means. But
I think if I had to buy a printer, yeah, I guess I would get something like I don't know, like an Ender 3 V2 or something.
I might go. I would If I was getting an Ender 3, I might try the Ender 3 S1 now that they're out.
Yeah. I might also get a Sidewinder.
For a big printer, I think the X2 Sidewinder is probably, yeah, Al's probably got it right.
Yeah, he has 9 of them.
Yeah,
So those are his favorite printers for sure. Hmm.
heavily modified. Curious what heavy modifications. I guess Quinley's probably one of them. But,
Yeah, that's one of them.
I know you got like the Y-axis tensioner. That's the only thing I think that's annoying with Sidewinders is they didn't have a tensioner on the Y-axis, but
Strain relief on the actually the Sidewinder 2 fixed
the
that.
newer one has really nice strain relief, I think, on the bed now. I think the ribbon cables as well. Aw, any printer from 3DQ is my favorite.
Luca doesn't realize we don't sell printers. I
Well,
know
we do
who
sell
that is.
upgrades for printers.
Yeah, we do sell upgrades. So any printer supported by 3DQ by Quinley is his favorite. Yeah, we kind of gone through everything. I
Yeah.
think this was a pretty eventful stream.
Yeah, if you've joined in the first half, you probably want to check out the second half, and if you join in the second half, you should check out the first half because there's a lot of cool, illegal, forbidden 3D printing
Forbidden
uh,
printing.
techniques in there. Yeah, it's been fun talking about it all.
So we should just say bye.
Yeah.
Yeah, if you have any more questions or want access to Steven's 3MS,
Yeah.
ping him in the Discord.
Let me know. We can continue the conversation.
Hopefully, yeah, I want to integrate some of this into our prints if we can, just to make them look
Yeah.
cooler at least.
Yeah, well, it could be something to do.
I feel like
Especially like the really optimized prints that we print for our own machines.
yeah.
Yeah, like things that print in base mode, you can pretty easily turn that into full control.
Anyway.
Yeah, sometimes you have to turn it into a math equation, though. That's annoying.
Yeah.
So
Well, lots
depends.
of stuff to think about.
Yeah.
Cool. So, yeah, we'll see you all next week. Thanks for joining us again. Yeah, hopefully we're gonna have some. We'll see you again next week, and we're gonna have some really interesting stuff to
We have
show.
a new thing to show.
A new thing to show. There's always a new thing to show.
Yeah.
But yeah,
But this new thing's a really cool new thing.
this is a cool new thing. Working on printing a 576-hour print project on this Ender 3, 24 days of continuous printing.
Well, that's really cool.
Post updates in the Discord.
I want to see what you're printing now.
Yeah.
Yeah, share that, please, because we'll be really interested to see what you're printing. It takes 576 hours. It must be like a full costume or something.
This is the best stream besides the QB launch so far. Well, I'm
thank
glad
you.
you enjoyed it, Al. I thought it was a cool stream too.
Yeah, well, I think if you ever want to try some of this stuff, let me know because it's a lot to get through on like full control or even these Cura hacks. So I can share you the 3MFs. I'll share you the full control files that I use, like the source code for these things. Just let me know and I'll share it with you.
Oh, we're getting green screened away. Yeah, we'll cut once more to the to all of our beautiful prints.
Yes.
And
Transition 2.
oh yeah. Awesome.
Yes. What a nice background for a stream. I'll make it look all nice again.
It'll be cool, yeah, when we start combining some of these concepts. Yeah, it'll be really interesting to see how this plays with Quinley Vision.
Yeah, we should do some like tests, some like try to break Quinley Vision essentially.
Yeah,
I want to see how
that's going to be interesting.
How it works.
Oh, okay. I'm looking forward to Ben posting updates on Discord. Oh, also something to keep an eye out. We have like time lapses set up now. We have like so many time lapses going, so keep an eye out for those.
Yeah, there's some new posts coming on our YouTube channel over the next few days. So if you're not subscribed already, hit subscribe. You'll get those notifications. The videos are cool. You're gonna want to see them. Yeah, and I think
I'll give a close up.
You might see something to do with these eggs in the near future. Hint, they were all printed autonomously without us changing anything between prints. That's as much of a hint as I'll give.
Well, hopefully we'll see you on the next stream. And apparently the next stream is going to be better than this one.
It's just, we're just going up.
Yeah,
It's always better.
yeah. So look forward to that. Okay. We should end this before we go on forever. It was nice seeing everyone again. We'll see you next week at the same time.
Bye, everybody.
Goodbye.
See you next week.
Goodbye. Okay, goodbye for real.
Bye.